AWS Lambda. And then we're going to analyze the results to see what insights we get from what we see. And then based on that insight, we're going to make some sizing suggestions or decisions. And then I'll show you in a demo about how I have gone through that process of creating this. So first things first. So the model is a decision tree. It's created by scikit-learn. If you follow that link, you can actually see that is a part of Amazon SageMaker Advanced Examples. And then we're going to use CloudFormation in order to create a stack. And that stack includes API gateway, includes Lambda function. The Lambda function is fronted by that API gateway and in turn calls upon the endpoints that we have created in SageMaker. And then we start with a single machine, and then we're going to do autoscaling and see what change autoscaling, what impact autoscaling is going to have in the load testing that we do. So, and we have used an M3X large machine for a specific reason, that we wanted a machine that is optimized for memory in order to show you what insights it can give us when we go to the final results. So the stuff that we need to do first, some installations. You can do it on your own laptop on that you have AWS basically credentials and AWS regions and configurations set. So you can simply use the same laptop, the same computer, the local machine that you use in order to work with AWS services. You can use it, and it basically, the serverless is going to connect to your serverless infrastructure. So how do we install it? We install version 1 of the framework because version 2 doesn't really quite work with artillery. It's got bugs and it's got issues. So, and then not every single one of the version 1 works. So here, what I've done in here, I'm doing sudo npm install -g serverless at1. That at1 and the end of that command is telling us, give me the latest of the one. I think it's 1.83. So that should work. We additionally need to install serverless artillery that is going to fire up virtual users based on a configuration file that we give it. So it's another simple installation, npm install -g serverless artillery. Then we ensure that we have the proper Node.js. So 15, I tried different versions. 14, 15, 4 worked. First of all, if you use the 10x version, the first issue that you're going to have is a bug in workings of serverless, unfortunately. And then there is also the support for Node.js versions that there are in AWS Lambda. So we make sure that we have the correct version of Node.js. So then we do npm install basically n, and then we use basically n proper version to see what it is. And then we do create a new directory. So after that, we're going to create a local setting. So for every load testing, you can have a local setting because there are specific configuration files in there. So what we do in here, we do start a local setting, and that local setting that we have in here can be stored in a specific directory. So we create a directory, and then we do serverless artillery or SLS art configure. It basically creates a local copy of a bunch of files in there for you, and then includes a serverless YAML, which is the configuration file for serverless. So first thing we need to do, we need to find the Node.js runtime version, which is Node.js 10x by default, and change it to 14x to make sure that we don't get any errors at the deployment time. And then we do serverless artillery deploy. It deploys test load, basically some test load tests to infrastructure using CloudFormation onto your account, and then it just creates an basically random sample test just to do a deployment. What you need to do, you need to tell it what you're going to test and at what rates you're going to do load testing. Consequently, you can do SLS art script that creates an empty script called script.yaml, and then you can get a script.yaml, and then you can update that script.yaml for the purpose that you actually do have. So what do we put in there? So the simplest that we can do, so we have a config. The config is targets. First thing is target. In target, we are going to have the address to the endpoint for your API gateway. So what it is the common API gateway address, not the specific post or get or whatever. So what we have in here is something, if you go to the CloudFormation and you take a look at the stack that you have created, the output of the stack is what you see here. And after that, we're going to say we're going through phases. We go through 2 phases. There's going to be, in this example, a warm-up phase, and is going to be a max load phase. In the warm-up phase, we start with 200 arrival rate, which is the constant number of virtual users per second, and then we ramp it up to 600, and then we do that over the course of 1 hour. So that's a warm-up. And then in the second phase, for another hour, we start with a 600, which is the previous rate that we had, the endpoint for the warm-up, and then we ramp it up to the 800 per second, 800 virtual users per second, and we run it for an hour. So, and then which one of these things do we want to bombard with the artillery? And it's going to be the basically from API Gateway, what we'll see is going to be something called DT. We do the post. So actually, you see here, we have a post, but basically we're going to make a call to that post. So let's see some of the results after 1 hour. I ran this for 2 hours, and about 10-15 minutes into the first, or 20 minutes into the first hour, I added auto scaling. The reason I didn't run it once with a single and then with multiple machines, because there's hundreds, thousands, or tens of thousands of calls I've made. And those tens of thousands of calls cost a lot of money. Don't try it at home unless you're really doing it seriously for work. So what we ended up with at this point, this screen grab is coming from CloudWatch when I had only a single machine, right? So at this point, I had run 37K.6 thousand invocations, the orange number. They all have been on a single machine, the blue, but there has been massive number of 500 errors. There's 17.3 thousand. Model latencies to the roof, 207 milliseconds, and overhead latency 5.74. Just looking at it, telling me something is not right, because with the SageMaker endpoints, and especially some simple inference like what we have with the Iris data set using a basically using scikit-learn, then we don't really expect more than 10-12 millisecond latency. So what can we do? So I went and created a basically auto scaling configuration. In that auto scaling configuration, I made it for maximum of 4 machines. At the point that I got this screen grab, I was running only 2 machines. So you see from the 40K invocations, half of running on one machine, the other half are running on the other machine, because the orange number 40.7 is basically the sum of total invocation, and the blue number 20,000 is the sum of invocation per instance. The first thing that you see is that the errors are gone, the latency down to 10 seconds, 10 milliseconds, and the overhead latency to 2. So that is a good place to be. So we know that to run this experiment, we need at least 2 machines to run. So I might as well start with 2 machines, make my first initial instance count 2. But we're not quite done yet. Where are they the correct machines that we're using? Are we